Here we are. So, welcome to another week in open source. We'll start off like we normally do with some announcements, and I believe Pavel, you have a module to tell us about.
Yes, we did a wrapper around the around the gist that Nate published recently to do the write access control. So let me send a link on it. So
Yeah,
it's
it's a good
basically
handy.
the API is, I guess the Arthur implemented it the way it was in the original module that you had, Racer Access. And so it also allows you to not only allow but also deny some operations. And basically it is supposed to play well with other two uh, access control and validation libraries that are over there. One is for the queries validation, and another one for which is called, I guess, which Vladimir wrote for validating stuff like the fields, the actual fields. So like those three libraries are, well, hopefully will allow to restrict all unwanted database operations.
Awesome. Yeah, but glad to see some progress there.
Yeah.
I haven't had a chance to check it out, but that's really cool.
Can you, sorry, Pavel, can you link me to the one that Vladimir wrote?
Yeah.
And the other one you mentioned was, I think it's the Derby server.
It's server query.
Server query, that's right.
Yeah, so there are three of them for different purposes.
Right. Yeah, I looked at the server query the other day, and it looks pretty cool. Haven't tried implementing it in the thing I was doing, but looks good.
And this third one is from Vladimir. It's called Racer Schema. He implemented a JSON schema version 4 validator using the Z schema.
Oh, that's cool. Do you know much about how it works? I haven't had a chance to read it yet. But
I don't know the details. I just know like how to use it. That's all.
Okay, that's cool.
Sweet. Definitely check that out.
Yep.
And you mentioned you guys went through sort of a stress test with real users.
So this week we had a big battle test of our application. We had about, I guess, 12 or even 15 sessions, each of which had about 80 to 100 students simultaneously on a website in a single game. They were playing with each other, changing the same stuff, and Derby handled it very good. So like we didn't, the server didn't like actually crashed. So we had a bunch of errors. Frequently usually there was just two errors. I have posted them into the chat. Like one is in ShareJS, another one is in Racer. Like Racer was talking about document already exists very frequently. So like Joseph told that it may be because two users trying to create the same document simultaneously. So that may be the problem.
Yeah, I mean that's what the error means. I don't know how it can actually happen. We've had it in the past. I'm pretty sure we had it because of hooks. So we had code on the server side that was creating a document named with in some condition, and that was running twice. But I mean, maybe Nate can speak more to that, why that was happening. I can't remember all the details.
I don't know off the top of my head. We haven't actually investigated it. We still have some of that error happening though. Joseph added some stuff to make it so you could get a little bit more information about error messages, but I haven't kind of wired it all the way through to the racer level. So what would be very helpful is if you could tell what document it was talking about to see whether it's a bug in your app or bug somewhere else.
Yeah, so yeah, that's why we're going to fork, I guess, the racer and ShareJS and add additional login to those before this errors getting fired.
It should actually be passing back some of this information. So actually, the plan was for Racer to propagate it out a little bit better. So for now, ShareJS is kind of like API lockdown because we've published an actual version of it. But what Joseph and I talked about is probably instead of having the errors be strings, they should be objects so that we can pass additional metadata along with the error. So what I might do is just change that now in Racer since I haven't actually like christened it 0.6 officially yet, and that might just like work better in the long run.
Yeah, this should be better because currently it only says like document already exists and that's all. Without we're like clueless what can cause it right now.
Got it.
And another one is like OP acknowledged called from a null state, and the golden phrase, this should never happen, but it happens.
That's a Joseph error message, if I've ever seen one.
Is it ever?
So what do you think, Joseph?
Well, it should never happen, so I don't know why it's happening. Yeah, I saw that. I can't remember off the top of my head why, or the exact conditions that caused that. I don't know, let me pull up the code while you guys chat.
Okay.
Yep. So like basically we had like this very, very serious penetration test of the applications. So like 80 simultaneous users changing the same data, and it went pretty well. So.
Cool. It's good to hear.
Yep.
Did you run into a lot of memory leaks?
No, actually, I checked. Like the memory usage on the server was the same as it was before, like maybe 100 megabytes more after a day of like this really big car usage.
Okay. Yeah, a little bit of increased memory is pretty normal because as code executes, V8 will compile it and then store it, but it should level out at some point. We have a memory leak in our app right now that we're trying to figure out, but it could be one of many things, so that's why I asked.
Well, like I checked right now, and it's like 650 megabytes.
It's a little high.
Yeah.
If you don't have a lot of users connected. I mean, node processes, just as a point of reference, tend to start getting pretty slow at about a gigabyte of memory because they're basically designed for browsers where you don't really have, V8's designed for a browser, you don't have more than a gigabyte of memory per tab. So it's not really supposed to go much beyond that performantly. The garbage collector can't really handle it well. Anyway, rule of thumb, plus or minus.
Yeah, actually, like I noticed that it started to grow in sense of memory usage after we refactored our application to use many small Derby applications.
Mm-hmm.
So like we now have like 12 of them, and the memory usage went higher than it was before when we had only one Derby application. It was like 400 or 500 megs, and now it's about 700 megs.
Well, that's not necessarily a problem, but it's more the fact, like, whether it's growing without bound is the real concern.
Yeah.
So anyway, just keep me in the loop if you run into memory leaks. It's something I'm looking into right now.
Okay, sure. Oh, by the way, how do you handle those errors?
How do you handle errors that are like
critical, that can that break your application and it's just exits?
That's a good question. We do a couple different things, but the main thing we do is we just throw up a message that's like, hey, there was an error, and then put gray out the screen and tell people to reload the page, which obviously you don't want to do, but is better than leaving things broken.
And how do you figure out that on the client that there was some error happened on the server side?
So if you listen to, there's a couple things here. Let me
Well,
pull up the code.
if an error happens on the server side, then the server should crash, and the client will get connected and reconnect. Yeah.
Oh yeah, but do you mean like the document already exists as an error that's like caught on the server and sent to the client, right? So
Right.
It's not,
Yeah.
so it's not like a crashing the server error; it's handled correctly. Let me see where our code is.
Oh, also there was another third error that happened once in share. It is when there was like really high load, when like hundreds of people were simultaneously changing one single stuff.
Yep.
We get an error on all of the clients that got document version from the future.
Oh.
And when this started, like it started to just, whenever it tried to update via the browser channel, it was throwing this error again and again, and the only thing that happened is to refresh the page on the client side.
That's kind of funny thinking about all this stuff with kind of a clear head from sort of spending a few weeks away from all those things. I should add some better recovery logic, just so the ShareJS document can fix itself and get into these sort of invalid state, which would be pretty easy to do actually, and then yeah, regardless of the problem, it should resolve itself. But what do you think?
We were actually talking about this, Joseph, and I realized there's a pretty likely case, which is the way that we're doing queries. This was actually something we were talking about this last week. If for whatever reason the query doesn't match right now, I think that you can get into states where like we'll determine that you're not supposed to get a document, and then it actually is wrong because of a race condition. At least the way we were doing things with like secondaries, although this might not affect it if you're just using a primary. And then that could cause this problem to happen because you like miss an op because you think it's not relevant. Although I don't know if that.
I don't think that works. Should be able to happen. There's certainly a race condition where if the secondaries, if we're polling on the secondaries and an op comes in and we ask the secondary whether or not the query now matches, and the query says it still doesn't because it hasn't actually processed the op yet.
Yep.
That can happen, and then it won't re-poll the query until it decides it needs to re-poll it again. And at that point, it'll say, "Oh, now the document matches." But there shouldn't be any race condition around like different around which version of the document, like not getting ops that it should have. That should be taken care of. Pavel, I was going to ask, what is your server setup when you are doing that stress test? Is it just one server? Are you using Redis or
yes, what? It was with the Redis, and it was just a single instance, no clusters,
Great. Okay. The thing, I mean, like, if you got some time, the thing that would be useful to track that down, I don't know, which maybe I'll need to do is just make like do more stress testing. I've got a monkey test that just like spins up a million clients and then makes them all try and edit the same document at the same time. But that doesn't have any it doesn't come up with any errors. It passes each time it runs.
Yeah. Well, I was tending to track it down, but like when we had this error, I just freaked out and like started to tell everyone to just refresh your pages, like to the professor, to the students, like, and I refreshed it myself. So like I just didn't. I lost the error log.
Yeah, that's why when there are errors, we just tell the user to reload. So here, I'll give you a bit of logic that we use.
Okay.
So we basically handle 3 different types of errors. This is CoffeeScript, so it's not going to be formatted super well. But basically, there's like the socket has an on error thing. And then the share connection has an error event, and the model has an error event. So if you don't listen, this is like a standard node event emitter. So if you don't listen to the error event, it will throw. But if you listen to it, you can figure out what the error was, and then we have this like post error function where we like track it, and then depending on the kind of error, we like are more or less aggressive about what we display to the user. And there's also a like model on error, but you should still definitely fail if there's an error because you don't know what happened really.
Mm-hmm. Can we just do the like server side reload the page? Oh, by the way, how to do it? How to reload the page server side?
There isn't a way. You can tell the client to not connect anymore, but you can't like. Well, I mean, you could write something if you want to.
No, I mean just like force reload it. Like if we can reload on client side by like app history refresh, right?
Sure.
But
I mean, you can write some code that does that, but there's not like an HTML, HTTP way of doing that.
Mm-hmm.
Yeah, you need to send a message to the client to tell it to reload.
Yeah.
Yeah. The other thing with this code to keep in mind is that we have this post error function which sends the error and some metadata to Sentry, which is one of the many bug tracking services. So it's also helpful in terms of like, when you're freaking out just trying to get things to fixed after the fact, you have a lot more stuff to investigate.
Yeah.
Mm-hmm. What servers do you use? Can you post
Git
it?
Sentry.
There's a bunch of them, but this is the one we're using right now.
You know the guy that made this Bugsnag?
Getting back to the version thing, Joseph, another thing which we were thinking about is when we're doing migrations, we are typically modifying a bunch of data that may propagate out a bunch of changes, but is very unlikely people care about. So what we end up doing, unfortunately, is like overloading a lot of the front-end servers, which are like processing through a shit ton of operations that really they don't need to care about in all likelihood. So what would be great is if we could just have a flag when we're like doing migrations or doing really, really large data imports where we say, don't publish, but do everything else, right? Like do make sure that there's no conflicts and like do the transforms if there are, but don't publish. And then
if you do that and anyone has that document open, then they'll get an invalid state. That's what'll happen then.
Yes, but it's a very recoverable state because what happens is you get another version later and you're like, wait a second, I'm missing a couple things. You go to the server, you get the missing stuff, and then you move forward.
I don't know that ShareJS actually recovers from that gracefully at the moment.
Oh, it does not. You get the op error from the future, I'm pretty sure. But it's the same actual problem. It's you'll miss some operations, and then we could catch you up. Share just doesn't do it yet.
Yeah, absolutely. Yeah, we can do that. Is the problem that it's like, where is the CPU loading the client? Do you know? Because if it's in the layer after middleware, then you could write a really easy middleware and add a metadata property saying like, hey, don't send this to the client, and then just use ShareJS middleware. Allow you to move.
I mean, sure, but like, there's various other places to put the optimization, but realistically, there's a lot of other stuff that happens, right? Like we send shit to Redis does a bunch of work. Like, it'd be better just to do none of that if it's very unlikely to be useful.
Yeah, that's true. Yeah, we can do that. Yeah, I want to do the change first that meant that they could handle getting operations out of order. Oh,
Oh
sorry.
yeah. I'm saying that's kind of blocked by that. But this is, I think, the same problem as the op from the future. It's like I think the client just needs to be okay with that, and then go, oh wait a second, okay, I can get those ops that I missed, and then proceed.
Yeah, absolutely.
Should be pretty straightforward. It's a lot like, remember how we decided that you should be able to edit stuff even if you fetched it and you're not subscribed. It's actually really similar.
Yeah, it's much easier actually, much simpler. But yeah.
But in terms of like why that's useful, it's kind of a similar, I think, pattern.
Yeah. Okay. Yeah, we can do that. Yeah, we pass an options object to the submit function these days, so we can just add another optional argument.
Sweet.
Yeah.
That would help a lot.
Okay. Well, patch is welcome.
Yeah, I know. Well, the thing that would be more useful from you would be the op for the future issue if you have time to work on it.
Yeah.
Because that would be like a little more involved. The other thing's pretty easy. Just not doing code is easy.
Right. Sure. Yeah. Yeah. That's true. Yeah.
Cool. Were there any other announcements, or was that it?
I think we're deep in the bugs, but
Yeah.
I believe Osman made a pull request for Derby site just to add the getter link, and I just need to deploy that.
Yeah, I've also made a component based on Derby sync example, where we have a draggable table.
Oh, cool. That code's
yes.
really old, actually. That's cool.
Yeah, but I've modified it. I've added sortable headers. I think it's useful for table, not only to have ability to change using the mouse rows, and also everything has columns to change, but I also leave rows to change and edit sortable headers here. And this thing requires data to be in a certain format. So I was thinking about how to make it more universal, so it could be applicable for many cases. So
Nice. Yeah, that's pretty neat. Are we adding this to that examples thing that you've been doing, Ian?
I'd like to. Yeah, looking at this, is there a reason why you name the files like this and not just index?
There is that a reason for what?
Oh, well, it's just like, I guess normally in a component we'll name the code files just index.coffee, index.jade, index.sass, right?
Yeah, but it's not and I haven't made an npm module. It's
Oh, right, yeah.
yes.
Yeah, no, but this looks cool. And so yeah, bringing up that component examples thing, I would like to keep adding things to that. And let me find, well, so yeah, another.
But yeah, I think when I will made it as a npm standalone npm module, and probably will add some example that it could perfectly moved to Derby example, if you will.
Awesome. Yeah, just add example.coffee or whatever, and that'd be great. And then I guess last week you guys, Pavel, you showed the grouped bar chart component, right?
Yeah, it's a standalone module, so.
It's a standalone module, right? And if we could add an example copy in HTML to that, then we can include that on the components example repo too. Yeah, I have a backlog of components I need to add as well. So. Get on that. Yeah, that's sweet. Thanks for sharing that. There you go. Cool.
Okay, so also I wanted to ask you guys about how do you, what is your server setup?
We have everything on AWS currently. We have a number of different services. So we'll just talk about probably the main app, but basically routing through Route 53, which sends requests, DNS to a particular load balancer. That load balancer, Elastic Load Balancer, standard AWS stuff, connects to a number of different front-end servers. Currently, this is all in one data center. It'd be cool if we could do multiple data centers, but haven't done that yet. So the different front-end servers are in different availability zones, which gives you some control over failure. And then those all connect to a clustered Mongo. So there's like Mongo primary with 2 secondaries. But it's not sharded. It's all just like one Mongo database for now. And then also a Redis server. So there's just one Redis server currently. And then the front-end servers, each on them have like 5 processes that handle connected clients, as well as one that does rendering for server-side. So the way that we orient those requests is with Varnish, which just sends traffic to different servers based on session cookies. So that's the basic setup. And currently, we do have like a specialization of servers that only handle server-side rendering requests and servers that handle clients that are connected, which is better because they do different stuff, and so specializing tends to be better for performance. So things that are longer running don't block out things that are shorter running, basically. Like server-side rendering obviously requires a lot of continuous CPU, so it kind of blocks for a while. So better not to do connected clients that way. And then what I'd really like to do is to break that out even a little bit further, where the connected clients are actually different than the server rendering, because a lot of times we could leave clients connected without updating the code, versus like when we want to update the code, we need to refresh the servers that are server rendering, as well as all eventually the clients. But we could leave the currently connected clients connected. So that's a high level. I mean, it goes pretty deep, but starting point.
Yeah, well, that's pretty complicated setup you have over there.
That's the start. We have about like here, I'll check. We have about up to about like 1,000 sessions at a time of people connected.
Well, we had like maximum was like 200, I guess, something like this. But still, we only had like one single instance, and everything was running on it, like Mongo, Redis, everything.
Oh, wow.
On server.
Yeah, I mean, our app also per session requires quite a lot of resources because we load a ton of documents per connected session.
Yeah, each session, each client has thousands of documents, so it's yeah.
So we probably are throwing more hardware at the problem than would be necessary if our data were in fewer documents, basically.
Oh, Joseph, do you have the link to the video? Did they send you a link to your talk at the JS meetup?
No. I still don't have that.
They haven't sent it to you yet?
No.
Oh. Because I was going to say that'd be a good video to watch. Joseph talks about, I mean, it's also kind of high level, but like the structure of how we set it up and everything talks. And do you have slides online? You have a nice diagram.
I can pull up. let me just pull it up now.
I guess it's
I have it on my head. But I mean, I should just put it on SlideShare, even if I don't, even if nothing else happens. Keynote layer.
Yeah, because once we see that video, we should put it on the Leopard blog.
Yeah. This is the diagram, I think. This is the one you're talking about.
Yeah.
Yeah, I mean, this is sort of, how things are set up at Lever, that there's a Redis server and a MongoDB server, and like a MongoDB cluster. Then there's a whole bunch of front-end servers. And then like AWS then like terminates SSL, and there's load balancing. And then in the browser, then the ShareJS client talks to the browser channel, and then Derby does that, and then Lotus and stuff like that. Not included in this diagram is all the middleware and Racer, which are important, and the task queue and some different things. But yeah, that's sort of how it's all set up. And that helps with that.
Cool.
The last one.
Yeah, we'll need to set up something like this, I guess, eventually.
Yeah.
When we'll have the same amount of users as you do.
I mean, it sounds complicated, but this isn't actually very complicated as far as these things go. Like, I think that you can't avoid learning about like DevOps stuff if you're going to be running a web service. I think that's just how it goes.
Mm-hmm. Okay, cool.
Cool.
Yeah.
Any questions?
I think we've been doing questions.
Sure. I never.
Oh, by the way, like one interesting thing that we because we didn't have those clusters set up, our app was crashing, and we almost lost our one of our clients because of that. But then we found that there is this thing in Node.js called domains, which allows you to catch all of those unhandled throws and like errors that your code or like underlying libraries can throw. And like this actually helped us to get this thing running without any crashes.
Okay. You should be careful. Like, one of the problems is that if your server crashes for a reason that you don't understand, then like the question is, what should you do? And I'm very much in the camp of if the server crashes and you don't know why. Sorry, if an exception's thrown and you don't know why the exception's thrown, then you should probably just restart the server. And you should make it so that your server can restart easily without breaking anything. Like, you can obviously just catch and eat the error, but then if that happens, then your server may still crash, but instead it'll like run out of memory and be really slow before it crashes, or like the experience is still broken for some of the users. And if you restart the server, then the clients will reconnect, and they'll have a moment of interrupted service. But yeah, mind you, obviously it helps when you've got multiple servers. But yeah.
Yeah, I guess like cluster setup helps with this. Like even when first server gets down, another server is still working, so all clients get reconnected to it.
Yeah. Oh, and by the way, in that diagram, we've got like 12 physical servers. There's also each of those servers is running like 4 or 5 instances of our app. So there's like 2-tiered load balancing. There's AWS, and then which balances between the machines themselves, and then each of the machines has Varnish on it, which does internal load balancing between all of the instances that are on that machine. So that way, like if rendering takes a couple seconds, then other users' service isn't interrupted because they're using different instances of our app on that machine. But yeah.
Okay, makes sense.
Yeah. Yeah, I mean, it'd be good to put together a guide at some point of like, this is like if you want to run production like us. I certainly started that using, well, I say us, but I'm not there anymore. I wrote, I started that by writing up and documenting how we're using Docker a fair bit, and yeah, but there's a lot of stuff around like browser channel and exactly how to set that up on AWS so that it load balances correctly that I'd like to put up. Although that said, I would actually like to move to WebSockets. So ShareJS 0.8 is going to come with WebSocket support like built in. As much as I like the idea of like, and I'm going to keep the idea of like, oh, you can just pass ShareJS a stream and blah blah blah. I'm probably going to just make WebSocket support native, and that's going to be the default, and that's going to be what you should probably be using, unless you want to support all the browsers or something, and then you can, then you can go and figure that out yourself. Maybe I've been thinking about it. I think going back and forth on the issue, but like, yeah, WebSocket support. I think WebSockets are kind of easier to set up in some ways. We've had some various cookie issues on AWS with the load balancing that we didn't have to deal with. Anyway, I don't know. Things, code. Yeah.
Yeah, WebSocket support, like if it's gonna be built into ShareJS, I guess it's gonna be awesome.
Yeah, well, I mean, what's his name? One of your people.
Arthur. Arthur.
Arthur, yeah, WebSocket support, and so yeah, that's probably, I don't know, it might be better. Probably, yeah.
Yeah, like we started our when we were using it, like I guess on Monday, we used it with WebSockets, and it worked really well. But we didn't have so many users. We had like about 50 users simultaneously running a game. But then, like with another class, we started to have our server crashed, so we decided to fall back to a simple browser channel, and then like we have tested with only the browser channel and with like 100 students simultaneously.
Interesting.
So I don't know how WebSockets actually. Well, when we have tested on 50 students, it was great. So like it was really fast and it was really responsive.
Because in theory, WebSockets should be less resource intensive than browser channel, because browser channel needs two TCP connections, ends up with two TCP connections that get torn down, and like they go up and down a lot more frequently than WebSockets, which only needs one TCP connection. So that's unfortunate. I'd like to know why that is. I think that an iOS's WebSocket library, I'm not sure which one you're using. I think that's reasonably well load tested. Anyway, there's something going on there that it's probably worth getting to the bottom of at some point.
Yep. Well, we're going to test it with WebSockets, I guess, maybe next week. On another day, we'll have a big test. I guess we'll turn on the WebSockets again, and we'll let you know how it went.
Cool.
Like basically, we're now on the stage where we have lots of professors and students playing in our application. So we'll see how it performs.
That's really exciting.
Yeah, that's awesome.
Yeah. Awesome and scary.
Yeah, welcome to the game.
Yeah.
Cool. Well, unless there's other questions, maybe we should all get back to writing code.
Yeah.
No, I guess I don't have any questions.
Okay.
I don't.
Cool. Well, thanks for joining us. Same time, same place next week.
Yeah, sure.
All
Right. Thanks, guys. Good to see y'all.
All right.
Thanks for hosting. Bye, guys.
right. Yeah. See ya.
Thanks.